Welcome back to UGC Swayam MOOC on Biostatistics and Mathematical Biology. Today we are going to start our new module, and this module is about types of studies. So in this module we are going to cover many different types of studies that frequently used in biostatistics as well as in mathematical biology. So let us start this module with the first session, and this section is called Observational Studies. So what are the observational studies? So we are going to cover in this particular session. So an observational study is the study that collects the data from existing situation and it merely observes that existing situation. So it doesn't actually interfere with what is going on in the situation, right? For example, you are looking at the nature, an astronomer looking at the the night sky. So all these are observational studies or explorative study. A natural historian exploring a vista, a natural vista. These are the observational study. There is no deliberate intervention to the ongoing system. The observational studies merely observes and collect the data, right? So association between the smoking and lung cancer, for example, to do that, an epidemiologist all have to observe what is going on among the smokers versus among the non-smokers. So that is an observational study. So Antarctica expedition. So if a person is going to Antarctica to collect the sample, let it be a geologist or a marine biologist or a floristic or a zoologist. So all these are part of the observational studies. Or astronomy or public perception of evolution or historical linguistics. So historical linguistics is traditionally considered to be a non-science discipline, yet it is actually an observation study because it's not prescriptive, right? You're not actually interfering with the linguistics going on there. So the data collection does not intentionally interfere with the running of the system in all types of observational studies. So no interventions or no manipulation. So that is something else. That is called experimental study that we'll be covering in our next session. So the chances of bias is the main problem with this kind of study. The observational studies are prone to different kinds of biases and cognitive biases that we have covered in one of our earlier sessions. You might remember it. Lots of questionnaires that make the public hypochondriacal, that is actually the problem. So they always think that they must be having some kind of disease or something, that's a psychological effect because of lots of, the questionnaire surveys. Or deliberate errors for the better healthcare. So everybody wants better healthcare policies by the government. So they would say that we are not satisfied with existing medical insurance or medical care that the state is giving. So these are the chances of bias with the observation studies. So most of the curiosity-driven basic scientific research, also known as blue skies research, undertakes this kind of observational studies. So curiosity-driven research are, the norm is observational studies, while utility-driven research are mostly prone to do the experimental studies, right? So of course in this kind of observational studies there are no prior hypotheses. So statistical hypothesis testing is not actually a norm here in observational studies. So chance of finding, the chance findings matters here. The lucky find, so serendipity plays a major role. As explained to you in one of our early sessions, this is something to do with the paradigm shift of Thomas Kuhn rather than the falsification of Popper. So that is what in the observational studies plays a major role. So the trial and error is the strategy of this observational studies, and random and unexpected black swan event, the random event or the serendipitous event determine the course, the paradigm shift of the Kuhn. So what are the cons of observational studies? What are actually the disadvantageous factors of the observational studies? One thing is that various cognitive biases specific to the observational studies. For example, the Hawthorne bias. So the bias only because of the fact that somebody is actually observing you, so you are prone to do change your behavior. That is what the Hawthorne effect. We have already covered that. So observational studies are also open to the misinterpretation due to the lack of knowledge in the given field. So nobody is actually specialist in all fields. So they are actually tend to a lack of knowledge in that particular field. So for one example would be a natural historian might overlook the froth that he observed in a lake. For example, if you travel to polar region, I've recently been to Antarctica and I've seen this kind of froth running around, a froth on the sides of the lake. So if you are not really a specialist working on data, for example, you might overlook as this is something not interesting at all, but that fraud might actually play a very interesting, it's an unusual phenomenon. You know, if you dwell on it, or a rain which is actually kind of a blood rain phenomenon, you know, all these kind of things you overlook. Or if you travel onto a tropical rainforest and you see some kind of like insect, or kind of, you know, a camouflage insect that is quite hard to notice even, right, unless you are a trained entomologist, you know, who is working on the stick insect, for example, and you know, those kind of problems, that is actually what you call as a lot of biases on the observational studies. So now let us define what is a cohort. The term cohort is being used in most of these kind of biostatistical studies, especially for the epidemiological study. Cohort is nothing but a group of people. So cohort, the term is used only to refer the humans, right? The human patients, or a group of people whose set membership is clearly, clearly defined. For example, all students enrolling MSc Life Sciences Plant Sciences program of Central University of Punjab. So I clearly define my study group. So that is my cohort, right? All students of that particular program. So all smokers in India is not really a cohort. Why? Because that is quite vague. A smoker means what? If you smoke one cigarette in your lifetime, will you be regarded as a smoker? So you have to define it unambiguously, the terms, right? Here the smokers, the further definition is that where the smoker is defined as a person who smoked 2 or more cigarettes in the preceding calendar year. That is what the smoker is. Well, that's not a standard definition. I'm just giving you an example. You have to clearly define who your cohort is, right? So in epidemiological or biomedical studies, the cohorts are often followed temporally. So each patient, right, for example, a lung cancer patient, you are actually following the lung cancer patient, longitudinally, right? That is actually temporally. Temporally means time bound, right? So if you measure it today, then after 1 month, then after another month, so you are actually following the same subject again and again. So that is often the case with epidemiological studies. So there are 2 kinds of studies, in concern with the time frame. One is called longitudinal study, another one is called cross-sectional study. What is that? A longitudinal study, also known as cohort study, collects information on the study units or the cohorts over a specified time period. So it is something like a temporal change, not a spatial change, but the temporal change is being measured by the longitudinal studies. So cohorts are being followed temporally. That means temporally means time towards the future or towards the past. So that is what you call the longitudinal study. At the same time, cross-section study is like a snapshot at one point of time but different people, right? So the study collects the data on study units at a fixed time. So fixed time, that is called the, for example, today I collect from many patients. That is called the cross-section study. But the longitudinal study is that either towards the future or towards the past. How towards the past? Because you can actually look at the registry, cancer registry, and you can think about what are the causative factors. Or forensics, for example, you might actually be wondering how you can actually see that the cause of a murder, for example. You can actually look past, towards the past. That is also a longitudinal study. So many of the scientific insights are often overlooked today as a common everyday knowledge. For example, smoking causes cancer. So everybody knows it, right? Smoking causes cancer. But these kind of inferences are actually, or the trans fat. You might know the trans fat and lack of exercise causes coronary heart disease. So this kind of everyday knowledge we often overlook as like, it's nothing, it's everybody knows about it. But these are products of careful, meticulous, longitudinal studies, often spanning for decades. For one famous example is Framingham Heart Study that has been conducted in a village near Boston, the United States. And the study, is still ongoing. And that particular longitudinal study have revealed the association between lack of exercise and trans fat with the coronary heart disease. So most of the the scientific inferences are through the longitudinal study. That is very, very powerful. Now, what is crossover experiment? Crossover experiment is actually very simple. The same study unit, that particular unit, that means a patient, for example, that patient undergoes a treatment with the different drugs, or different interventions, for example exercise, during non-overlapping time periods. So for example, drug A, then drug B, never drug A and drug B, never. So it is always that one intervention, subsequently another intervention. These are non-overlapping period, right? That is what the crossover experiment is. As for example, sequential treatment of the laboratory animals with various drugs, and blood metabolites are being measured for each of these drugs. So that is what you call the cross-sectional, but here it is called crossover. Now what is called endpoint? Endpoint is nothing but clearly defined outcome of a study. So that is what you are being followed, right? Most of the temporal study, that is actually longitudinal studies, follow the cohorts towards the future event till the occurrence of the endpoint. So endpoint could be eutrophication of a specific intensity. So eutrophication, the algal bloom that actually in the lakes. So that will lead to a phenomenon called eutrophication. That could be an endpoint in environmental or biodiversity assessment studies. So species extinction could be an endpoint. If you are looking at the species diversity or the biodiversity or taxonomy point of view, the extinction is something like the death of the whole species of all over the world. So species extinction could be an endpoint, or presence of a disease, a lung cancer for a smoker could be an endpoint, or 5-year survival period after radical mastectomy, removal of the cancerous breasts is called mastectomy. So 5-year survival period could be an endpoint, or the death could be an endpoint. So that is what you call the endpoint. Now coming to which direction you go, either prospective or retrospective. There are two kinds of study, the so-called prospective study and retrospective study. So as the word says, a prospective study goes towards the future, while retrospective study goes towards the past, right? So both these studies are longitudinal. It's a time bound, right? It's nothing to do with one particular time, snapshot. It's not a cross-sectional study, but it's a longitudinal study. So prospective study, cohort is being followed for the occurrence or non-occurrence of the endpoint, while in retrospective studies, cohorts having a particular endpoints are identified and studied. For example, cohorts are the HIV positive patient, then we can actually see that what are the risk factors that might have caused that person to get this particular HIV disease. So that is called the retrospective study. For example, paleontology, phylogenetic reconstruction, historical linguistics, or use of registries, cancer registry, twin registry, to compare the causal factors. So all these are examples of the retrospective studies. Now another kind of study, that is called case control study. What is that? A case control study collects all cases, usually of a disease, and that meets a fixed criteria. And it also includes the control. So the control could be a person, the healthy cohort. So the cohorts which do not have that particular disease could be a group, right? So for the comparison, so the case and control are being actually compared for different parameters. Usually it looks towards the past because the cohorts are already having disease. So cases have the disease are identified, and then the versus control, right? So the cases and controls are compared with aspect to various characteristics, and usually these kind of studies are retrospective. It looks for the causative factors involved with that particular disease, right? One interesting example is called genome-wide association studies, or GWAS. So whole genome sequences of the cases and then controls are thoroughly compared. For example, breast cancer. Cases are the breast cancer patients, while controls are the healthy people who do not have the breast cancer, right? So there is no breast cancer for the control, while the cases have breast cancer. The whole genomes are sequenced and compared thoroughly to see some specific mutations occurring only in the case of cases, while the mutations are absent in the case of healthy. So where these mutations are happening in the genome, so that particular thing you can actually comes with this kind of correlation. So you can identify certain genes that are expressed, or that particular genes are that mutations happens only for the cases, while absent for the controls can be identified by GWAS study. And if you want to do the expression analysis, for example, certain genes that are expressed only in the case of cases while not expressed in the case of controls, for example, oncogenes, or the cancer causing genes. So all these things you can do with a comparative transcriptomics So comparative transcriptomics is about differentially expressed genes in cases that can be identified. So all these are examples of the case control study. In summary, there are broadly two types of studies in the statistics, classified according to how the data is collected, either observational study or the experimental study. An observational study merely observes and collects the data from an existing situation without any intervention, no experimental manipulations in it, right? The cross-sectional study is a type of observational study where the data is collected from many study units at a specific time period. It's like a snapshot of different cohorts at one point of time. That is called the cross-sectional study. A cohort, a term used in epidemiology, is a group of people whose membership in the set is clearly defined. An endpoint is a clearly defined outcome of the study or the observation. So that is what you call the endpoint and the cohorts. So in the case of longitudinal studies, the cohorts are being followed temporally, either towards the future or towards the past. So if you follow the cohorts towards the future longitudinally, that is called prospective study, while if you follow the same cohorts towards the past, that is called retrospective study. And in the case of case control study, cases and controls are compared for occurrence of the disease or many other causative factors, often temporarily towards the past. That is actually normally a retrospective study. One example would be genome-wide association study, as well as comparative transcriptomics that can be aid in to know the causative factors that is differentially differentially expressed or differentially present. The certain mutations differentially present only in the case of cases versus controls. So all these are examples of the observational studies, and remember, observational studies do not interfere with collection of the data from the subject. So it merely observes what is going on in the existing situations. We will see some of my students in Central University of Punjab. The students, whoever is doing the observation study, let us see one example in the university. Come on and see. So hello, today we have Ramanpreet Kaur. She is a PhD student here working in Central University of Punjab. So could you please introduce yourself?
Myself Raman. I'm working with Professor Anjana Munshi, and we're working on breast cancer.
Breast cancer?
Yes, breast
So what kind of samples do you work with?
So we're working with the blood samples.
Okay.
We're collecting blood samples from Guru Gobind Singh Medical College and Hospital. Actually, we have a collaboration with Baba Farid University and Max Hospital.
Interesting. So can I, these are your samples, right?
Yes, sir. These are the blood samples.
The blood samples. So
yes.
Do you collect it from different patients or the same patient over a long time?
No, so we're collecting it from different patients.
Okay.
Like I have collected 300 samples.
I see.
Yes, sir. From 300 different patients.
That's interesting.
And all of these patients are from Malwa background.
Okay.
Like Malwa is basically known as hub of cancer.
I see.
So we have collected samples from 300 patients from Malwa region of Punjab.
All right. So my first question to you is that, is it actually, do you do some kind of like manipulations the thing, or for example the drug, do you actually administer some drug and then study the effect of the drug, or you simply observe what is going on?
So actually we are taking blood samples from the patients at the time of diagnosis of the disease, not after the diagnosis or not during the phase of chemotherapy.
I see.
Okay, sir. But during the phase of follow-up, we are contacting the patient just to know that under which drug they are undergoing, which drug, like which chemotherapy is given to the patient.
Right.
So we can use those drugs in understanding the genetic alteration. Is there any relation of metabolism and the survival of
all right, interesting. So what do you do with this blood sample? Do you actually do the sequencing or SNP analysis? So
sir, we are doing both. We are going for exome sequencing also. Like in case of male patients, we are going for exome sequencing. And in case of other patients, I have collected like 300 samples. Among those, 6 were like male patients. Those samples were outsourced for exome sequencing.
All right.
And in rest of the patients, NGS was done, but that NGS was specifically for known markers, like the pathogenic markers, which are known very late in different ethnic groups.
Very interesting. So the Raman study is basically, it's not really a longitudinal cohort study, but rather it is a cross-section study, because it's like a snapshot of the patients at a given point of time, different patients, right? Then you are doing the same study for a longer time to see that how that actually the correlations between that.
Is there any correlation? Like we have isolated serum also from the patients, and we are trying to find out is there any particular prognostic marker in this region which can be used as a in further whether the prognosis of the patient should be good or bad, like at the time of diagnosis, and we can relate with the prognosis for the future outcomes in that patient.
Anyway, thank you so much, Raman. It's really fun talking to you. Thank you.